Let's apply Newton's second law to a couple of situations. The most simple is example 1. What is the net force acting on a 2.5 kilogram ball in free fall? We know that force equals mass times acceleration. And we have been told that mass is 2.5 kilograms. Be really careful that you remember that mass is kilograms or grams. If it's telling you newtons, it's not telling you a mass, it's telling you a force or a weight. But you might say, I don't have an acceleration. However, you have an implied acceleration. Because we've said that free fall is when the only force acting on an object is due to gravity. So its acceleration is going to be due to gravity, 9.8 meters per second squared. So our force is 2.5 kilograms times 9.8 meters per second squared. And we get 24.5, and if we look at significant figures, we're going to round this to 25. And the units for force are newtons. And 1 newton is equal to kilogram times meters per second squared. We just use the newton because it's simpler and easier than writing all of that out. I want to talk to you real quick about acceleration due to gravity. We are going to always count that in our significant figures because it is a measurement. There are technically several more decimals, but we are choosing to round it to 2 significant figures. So you need to take that into account with your answers. Let's do another example. In this example, we have 2 people pushing a stalled car. The mass of the car is 1,850 kilograms. So I'm going to go ahead and write that down before I read the rest of the problem. One person's applying a force of 275 newtons, and the other applies a force of 395, and they're pushing in the same direction. Now, I've told you before, anytime there's 2 forces or 2 objects, you need to draw a diagram. A lot of physics has to do with visualization, and most of us visualize better with a drawing or something to look at, as opposed to in our head. If you do it in your head, that's fine, but it can be harder for me to see what you're doing wrong, because I can't tell if you visualized it wrong or if you're using the equation wrong. So if you can, please sketch a quick drawing sometimes. So here's my car, and I'm not an artist, so my objects are dots or squares. And one person is pushing this way with 275, and one person is pushing this way with 395. And they're pushing in the same direction according to the problem. And the force of friction between the car wheels and the road acts in the opposite direction with 560. Now I'm going to say that this direction is positive. It'll make my math easier because now this force is negative. And it's asking you to find the acceleration of the car. And we know that acceleration is due to force, but there's 3 forces here. So it's important to realize that acceleration is due to net force, always. So to find the net force, we'll just add these up. Because they are linear in 1 dimension, we can just add them. We don't have to do anything special. We will soon get to ones where they're in 2 dimensions, and we'll have to use vectors to add those. So 275 plus 395 plus negative 560. And so our net force is equal to 110 newtons. So now we can solve for our acceleration. Doing F equals m times a, and if we're going to solve for acceleration, we're going to divide both sides by mass. And the calculator tells us 0.05945 and some more. I want to talk significant figures for just a minute. I didn't make a point here, and I should have, about significant figures. Because remember, if we change from adding and subtracting to multiplying and dividing, we have to round to significant figures in the middle. So since we're adding here, we're going to have it where it has no decimal places, which is what we rounded already, but I wanted to point that out. Now we're dividing, so we're counting significant figures. We have 2 and we have 3, so to round our answer to 2, we have 0.059. And we know our units for acceleration are meters per second squared. We also know that a newton is really a kilogram times meters per second squared, and our kilograms cancel out. So our answer is 0.059 meters per second squared.